All right, let's just dive right into this. Welcome to this explainer. Today, we're exploring something that is, honestly, absolutely fascinating. It's happening right on the cutting edge of autonomous commerce. We're talking about a massive shift in how the internet actually operates, specifically focusing on FluxA and this brand new payment infrastructure being built for AI agents. You know, if you've been following the AI space, you already know these agents are getting smarter by the minute. But today we're looking at how they actually get real purchasing power.
This quote from Sky Zhang, it just perfectly frames the stakes of our whole discussion today. I mean, think about it. AI agents are climbing this permission ladder. First, we gave them code access. Cool. Then we let them operate in our digital environments. But that final rung, financial access. Handing an autonomous agent a literal wallet is the highest, most powerful, and, let's be real, undeniably the riskiest rung on this entire ladder. When an agent can spend real money, its potential absolutely skyrockets, but so does the blast radius of what could potentially go wrong. And that is the exact problem we're solving today. So here's our roadmap for this explainer. We're going to hit the AI payment bottleneck, unpack this new ternary risk model, explore intent pay and the financial harness, break down the 4 pillars of security, and wrap up with becoming agent ready. Let's get right into it. Section 1, the AI payment bottleneck. And basically, why our current setup is just so incredibly limiting. Think about how we pay for things right now. Every single payment requires a human tap. You can build the absolute most brilliant proactive AI agent in the world, an agent capable of researching and negotiating complex, multi-layered tasks, but the second it needs to spend 2 cents on a tiny API call, it just stops. It has to wait. It essentially turns your brilliant, expensive supercomputer into a super needy assistant constantly tapping you on the shoulder asking for your credit card PIN. It loses all its context. But the solution is what we call intent pay. With this, one signature from you unlocks an entire mission. You sign off on the main purpose and the budget up front, and then the agent just runs autonomously. Moving on to Section 2, the ternary risk model. This is a massive paradigm shift that essentially throws out decades of old legacy banking logic. See, the core issue with the old way of doing things is this binary risk model. Historically, payment risk has always been judged strictly between 2 entities, a human user and a merchant. But what exactly happens when you introduce an AI agent into this mix, using that exact same account? You get this massive problem called behavioral ambiguity. The bank sees an action, sure, but they have zero clue if you clicked the button or if your AI agent executed a script on your behalf. It's completely indistinguishable. And that makes attribution and accountability basically impossible. So to fix this, FluxA's introduces a massive shift, the ternary risk model. We're no longer looking at 2 parties here. They've actually separated the AI agent out into its own auditable, completely distinct entity. So now the system constantly evaluates the interactions between the human, the agent, and the merchant independently. The human gives the authorization, the agent executes the actual invocation chain, and the merchant settles the financial risk. It's brilliant because it restores total clarity to the whole process. When you think about how this builds a totally new risk landscape, it's pretty wild how drastically things have changed. Take account takeover, for example. We used to just try and detect if someone other than the user was paying. Now, well, the whole point is that humans are explicitly authorizing non-humans to pay. Or take fraud. We aren't just trying to protect humans from phishing scams anymore. We actually have to protect the wallet from the AI agent itself having a reasoning error or, a hallucination. But the craziest part is anti-money laundering, or AML. Previously, if a bank saw high-frequency, low-value, machine-like pinging on an account, that was a massive, sirens-blaring red flag. Now, in the agent economy, machine-like patterns are entirely normal. It's literally just how AI does business. Which brings us to Section 3, intent pay and the financial harness. This is all about how we actually maintain financial control. The way this actually works in practice breaks down into 3 really elegant steps. First, the agent drafts its intent. It reads whatever task you gave it and proposes a specific budget and purpose. Second, you just sign off on that once. And third, the financial harness takes complete control. You can think of this harness like an invisible leash tied directly to the agent's intent. As long as the agent is spending money on mission, let's say it's buying data for your research project, the harness just automatically lets the payment right through. But the very second the agent drifts off mission and tries to buy something totally unrelated, that harness snaps tight and instantly blocks the transaction right at the wallet level. Now, what's actually powering that harness underneath is the AEP2 protocol. For these agents to negotiate with merchants at lightning speed, they embed one-time payment mandates directly into their API calls. This gives the merchant instant, ironclad confirmation that the agent is actually good for the money. But here's the kicker. Because these are often tiny micropayments, we're talking fractions of a cent. FluxA uses zero-knowledge batch settlements on the Ethereum virtual machine. This means they can process hundreds of these machine-to-machine microtransactions with zero fees and then just prove them all at once later on. It's the secret sauce that makes the math of AI commerce actually viable.
All right, Section 4, the 4 pillars of security. Let's dig into the FluxA risk modules. FluxA basically uses these 4 highly interconnected risk modules to keep everything safe. First up, you have the agent identity graph. This ensures these agents aren't just invisible black boxes anymore. They actually have persistent behavioral fingerprints and a historical credit record. Second, there's intent mandate semantics. This one is huge because it protects your wallet from malicious prompt injections. If some bad actor tries to trick your agent into sending them money, the system instantly recognizes the semantic mismatch with your original intent and just kills it. Third is task chain risk enforcement. The system actually logs a fully reviewable playback of every single step the agent took, which is amazing for post-hoc auditing. And fourth, model drift. Say your AI model starts hallucinating over a long period of time, and its decisions slowly, subtly drift away from its core instructions. The system catches that behavioral drift and automatically cuts off the funding. So when you put them all together, these pillars create this incredible safety net that catches everything from malicious hackers to just, simple AI confusion.
And finally, Section 5, becoming agent ready. It's time to prepare for AI buyers.
To put this whole thing into perspective, there are over 134,000 AI agents currently operating with FluxA wallets, over 130,000, and they are actively making over 200,000 payment requests every single month. So the absolute crucial takeaway here is that this is not some far-off science fiction. This isn't a roadmap for 5 years from now. The autonomous economy is scaling rapidly, and it is happening right now. And what that means is businesses have got to adapt quickly. Think about the before state we're so used to. Right now, a human goes to a website, reads this beautifully designed HTML pricing page, and slowly types in a credit card number. But if an AI agent hits that exact same site, it just gets a 401 checkout error because it doesn't have a human session and it bounces. To the agent, your business is totally invisible. But in the after state, an agent-ready site hosts this incredibly simple file, just a .md file called skill. The AI drops in, reads it, gets a machine-readable API quote, drops in its payment mandate, and boom, the transaction is settled instantly, frictionless, one single round trip. So how do you actually make this actionable for your own business? Well, FluxA provides 4 really straightforward deployment primitives to make you agent-ready in minutes. Step 1, discovery. Just publish that skill.md file so agents can easily index your capabilities. Step 2, auto-onboarding. You've got to let the agents negotiate access and sign terms without needing a human slowing down the loop. Step 3, agent-native payment. Offer request-level pricing that these agents can just embed directly in their calls. And step 4, settlement. Utilize USDC stablecoin rails. This is vital so you can actually accept those tiny sub-cent payments without traditional credit card fees just eating up all your margins. We are literally standing at the edge of an era of massive scale. We're looking at a vast API and skills marketplace where software is autonomously buying from other software. We're talking about a completely transformed content economy where AI just pays microcents on the fly to read articles or access fresh data sets. We're going to see highly measurable agent interactions and an absolute explosion in AI e-commerce, where agents handle everything from your everyday procurement to complex supply chain purchasing, completely on their own. So I really want to leave you with this final thought. The friction of the old binary financial world is actively being stripped away as we speak. The ternary risk model has arrived, the financial harnesses are firmly in place, and AI agents are actively out there roaming the internet with fully funded wallets right now. So the ultimate question you really have to ask yourself is this: when AI agents become the primary buyers on the internet, is your business ready to make the sale? Thanks so much for joining me on this explainer, and I will catch you on the next one.